to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. We do not have a quorum at this moment. Okay, I'm sorry.
Councillor Olson.
Here.
Councillor Fennessy.
Here.
Councillor Bender is excused. Councillor Sweeney.
Here.
Councillor McDonald is excused. Councillor Mazzolia is absent. Councillor Finsland.
Here.
Councillor Herrick.
Here.
Councillor McKenzie.
Here.
And Councillor Brown is excused. Right now, we don't have a quorum. We need 7, so the meeting can't be called to order and no action can be taken, but I think the mayor would like to proceed with the Kestrel presentation.
Yes, we have with us this evening Steve Surfling. He's the Chief Operating Officer for Kestrel Aircraft. And Steve is joining us with a presentation on Kestrel, the Kestrel Aircraft project, bringing us up to date on where they are with the certification process and other matters that they're working with. Steve?
Hello, I am Steve Surfling, COO of...
Steve? There you go.
Now can you hear me? All right, I'm Steve Surfling, COO of Kestrel Aircraft. Thank you, Mayor Hagan, council members, for inviting me tonight. I have a presentation that will go very, very fast because I have in March, we did a 3-day presentation to the FAA, a little over 300 slides, and I had to try to pare that down to say, here's our progress. So once I get going here, I'm going to go very, very fast. You know, I'll take questions at the end if you would like, but initially I'll go fast. So first I want to just update you on Kestrel market opportunities. There's really five focus areas that we're looking at. As a step up for high performance airplanes like the Cirrus, many Cessna airplanes, Piper, Mooney, the traditional turboprop market, and these are our main competitors here. PC-12, the Cicada TBM 850 and the Piper Meridian, and also in that group are aging twin turboprop airplanes. And as an alternative also to the light jet market. And then there's a air taxi market that is we call it a potential market because so far it hasn't evolved. It's still evolving. We don't have any of those airplanes in our business case, but when that market evolves, we'll be very strong in that market, we believe. And then there's a rapidly expanding international market, especially Brazil right now is a leader in that, but India and China are emerging. There'll be a lot of airplanes of this category to sell. Today I'm going to focus on the traditional turboprop market and the light jet market. So show you a little bit about those kinds of airplanes. There's 6 main ones here that we look at. The PC-12 in the top left corner, the TBM 850, those are our 2 closest competitors. The Meridian is one that Alan Klopmeyer flies today. That's a little bit further away from us. And then a representative of the aging twin fleet is in the bottom left is the King Air C-90. And then 2 light jets are the Mustang and the Phenom. And what I have here are the prices of each of those. So they go from $4.6 million for the PC-12 to the highest price one, and the lowest price one there is $2.2 in the Meridian. They vary in speed. The closest one for us in all of these is that top middle one, the TBM 850, 3.4 million, 320 knots. And the last number is the cabin volume. So you can see the PC-12 is quite large. So our goal is to have our aircraft priced around $3.2 million. It's 320 knots, so it's the fastest of the single-engine turboprops, same speed as the TBM 850, but our secret is we're going to beat them by a little bit, and we're going to be priced less than them. And our cabin volume is quite a bit larger than the TBM 850. So we're very comfortable with our niche, but this is kind of what defined our, these airplanes here are the ones that defined what we're going after. So here's a real quick overview of what the airplane is. It's primarily made out of carbon fiber composite, very large windscreen, very large cabin windows for good visibility, and I'll show you more on that later. Differentiator here that we have in the engine is the Honeywell TP331 engine. It's a direct drive, 1,000 horsepower. It's actually 1,650 horsepower, but we derate it, so we have plenty of margin to grow that if we need any more performance. Mechanical control system, that just means conventional controls, except it does have a side yoke. If you've ever seen a Cirrus where the yoke is off to the side, single grip, very similar to that. Very wide, comfortable cabin, seats 1 pilot and 5 passengers for a standard configuration, but we do have some options for that, and I'll show that later too. Integrated avionics system, very state-of-the-art there. Tricycle landing gear, that just means 2 main gears and a forward nose landing gear. Anti-icing system for FIKI. FIKI is flight into known ice. And we're unique here, and we use a system called EMEDS. It's electromechanical expulsive de-ice system. So it kind of bangs the ice off the leading edges. Performance goals, as I said earlier, 320 knots at flight level 2,800. Our airplane will actually go to 31,000 feet. As you climb higher, turboprops lose a little power, so the maximum speed is at a little bit lower altitude, but you get maximum range at higher altitude because of less drag. But we'll go, this says 1,200 nautical miles. That's actually 1,300 nautical miles is our goal. Easy to fly. It'll be day-night VFR, IFR, so very, very capable airplane. So I want to talk a little bit about our most valuable resource. That's our people. We have a very experienced staff of engineers, designers, and technicians. Advanced degrees in all disciplines, from PhDs to BSs, but also aerospace welding certificates, and technicians are very experienced in composite construction. These 2 designees here, the FAA DER and DAR, the DER are engineering representatives, so they can sign off for FAA certification requirements. The DARs can sign off for FAA build requirements. And we have both of those in-house. We have 4 DERs and 3 DARs. We have a very strong relationship with the FAA. Many of our staff, in the Superior staff, probably 60% came from Cirrus. So many of us, myself included, have several certification projects under our belt. These graphs here show the experience level. In the bottom right corner, show 30% of our engineers have over 20 years of experience, and 26% have 5 years or less. My goal as a COO is to have 25% new grads or new hires, these 5 or less, and 25% 20 years or more. So we bound both ends of that, and we're pretty close on that. On designers, we're more almost, you can see that graph on the left. We've got very experienced people and we've got inexperienced people, but 38% are more than 20 years. So that's plenty of experience in both of those disciplines. A designer, by the way, is typically they operate our CAD, and I'll show you some of our CAD, our computer-aided design systems. So jobs progress, when we first announced that we were moving to Superior, we had 50 full-time employees in the company. 53% of those were in Duluth, 47% in Brunswick, and none in Superior. And then in June of 2012, we moved to the Tower Avenue facility with 75 people, and 52% of those were in Superior. Today we're at 110 with 55% in Superior. So I'm going to go through the design process. There's a lot of slides, so I'll go very fast here. But airframe and structure, when we talk about airframe, this is the composite, the carbon fiber part. So there's the fuselage, the empennage and tail, the wing, and it doesn't show there, but the cowl. This diagram right here doesn't have the skins on, just so you can see the skeletal structure of the airplane. This is the fuselage. It's a one-piece carbon fiber skin. From the front there, it's a pressure firewall bulkhead. To the very back is another pressure bulkhead. And all the way in between there is one piece, all co-cured together. Up in the top right corner, that's saying we don't have no rivets, no corrosion, and carbon fiber lets you do that. That second bullet says shape maximized for cabin comfort. Carbon fiber or any composite material like fiberglass or carbon fiber allows you to shape much more with much more control than you get with metal. So many people are going with like the Cirrus is a fiberglass airplane, and the Cirrus Jet's carbon fiber. We're carbon fiber also, and it also helps you improve aerodynamics because you can control the shape totally for reduced aerodynamic drag. Here's where kind of where we're at. These on the coupons on the left, we tried very many iterations of different. Those pictures of in the left side are of the frame structure. That's when we pressurize this airplane, so it's like a balloon always trying to blow up. So we have to maintain that at 31,000 feet with an 8,000 foot cabin altitude. There's a lot of pressure trying to blow up this airplane. So these frames are designed to hold that structure. And we're in a development now. We have 3 phases. We're in the second phase. Those center 2 pictures, the top one is a picture of a fuselage section that we've made, and that bottom kind of octagonal looking thing is a tool to be able to lay up that. So we've done some tests to make sure that we can lay up carbon fiber material in that single piece fuselage, and I don't know what just happened there. Computer's rebooting. So I think it's configuring Windows. Should I hook up my computer, or would it be better to do this? Pardon me?
You said to hook up your computer?
I have my computer here. If it would be easier to do that.
Yeah, we won't shut it down.
I can just unplug this.
Okay. All right. You think you know what you're doing?
Oh, yours is starting to boot though, isn't it?
Yeah, so we
So
wait.
just yours will be just as fast as mine.
Okay, let's see.
While that's rebooting, this is the handout that we gave to the FAA. So all of these slides, 300 plus slides, we did 4 months ago. And while I was putting this presentation together, I was looking at this and I realized how old some of this is. So that's our progress is real time with this many engineers. We've got about 40 engineers and 20 some designers. It's real time. Every time I turn around, there's new designs going on. So that part's just really going really well. We're very, very pleased with that. We have had other industry people come in, and I'm going to jump ahead maybe to a little bit of what I can just talk to. During our certification meeting with the FAA, we had 10 people from the Chicago ACL, which is they're our oversight office of the FAA. We had 5 or 6 people from the Small Airplane Directorate, which is like the overseer of all small airplanes. And then we had a few other FAA people. So I believe it was 17 in all, plus 2 or 3 on the phone. After that 3-day presentation, our program manager of the FAA ACO said, this, and we have a quote in our presentation, but the quote that he said was, this was the most professional, we call it a type certification board meeting, that I've been to. And I sit with my feet up on the desk because the staff presented, and they were fantastic. There weren't any questions that were asked that stumped us, and there were things that we had ahead of time identified as what we call issues, and those issues, 2 of them, the FAA said we can solve them right here, and only 1 that they added in addition to what we didn't think about. Or I shouldn't say we, my team didn't think about. Really, our team of engineers is pretty outstanding. Okay, I'll jump back into this. And when I get to that certification stuff, I'll skip it. Well, my presentation doesn't seem to be there anymore. There it comes. So I was here. Sorry about that. So I was saying that we're in that second phase of doing that fuselage development. And then the next phase is actually making the full-scale tool, which would end up with that single-piece fuselage, and then that'd be followed by first flight. That quote's a little hard to read, but it says, to design a flying machine is nothing, to build one is something, but to fly it is everything. That's a pretty famous quote in our industry, and flying, all those are very, very true. It just keeps getting more and more difficult. So the wing and empennage. This is the wing, that first piece that's in the front there, that's the main spar. About 40 feet long, that's the single most important part in the airplane, very strong. And it's just populating the skeletal structure. This is showing some of the design we have. That stuff that's going on the front is the electromechanical expulsive device for the de-ice. On the back are the flaps, the ailerons, the control surfaces. The wingtips were the last things that came up. So a typical wing, on the left side, it shows the fuel bay is inside the wing. So the ailerons and spoilers are outboard. The very, very long flap, and the reason for the very long flap is to keep the stall speed very, very low, so you can have a very slow approach, which allows you to get in and out of short fields. This airplane will really, really perform well there. And also on the left side, you can see the land gear folded up in there. That creates a very, very interesting engineering problem. On the right side, what it's showing is just a simple analysis, in this case, a load analysis. So since we know the weight of the airplane and a lot about the aerodynamics, we can put load on the wing to show what kind of stresses will be put on these. That's a very simple depiction of many iterations of that kind of thing to make sure we're building it strong enough. The empennage, the back of the airplane, both the vertical and horizontal tail. This little movie going on there is showing how some of the pieces that go into it as it's built. The colored photographs, again, the one with the tail section is what's called a deflection diagram. So we hold it tight in the front side where the two little holes are, and then put the loads on it, and it shows how much the airplane will move, so that we can tell binding and things like that. The little wing section is loaded up to show the lift effect on the horizontal. These are all the different systems in there. I'm going to just pick a few of these to go through to talk to you about. But every one of those different things start in the top middle and go around clockwise. Emergency oxygen, avionics, flight controls, engine and propeller, landing gear and hydraulics, fuel system, ice protection, environmental control and pressurization, electrical power. We have engineers and designers and technicians working on all of those systems, and we have a very good progress on those. So I'll show just a few of these. The engine is probably our most critical one. This isn't showing up very well, but again, I said it's 1,000 horsepower. But a critical thing here is that time before overhaul is 5,000 hours. The closest competitor engine is 3,500 hours. So that's a huge total cost of ownership positive for our customers. The single shaft design, that means it's direct drive from the turbine engine to the propeller. So when you put power in, it's just like a piston. It gives you immediate power. A typical turboprop goes through a pneumatic stage. When you put power in, it can be a 3 or 4 second delay. And that is a training issue between a piston and it's going to die again, isn't it? Maybe So anyway, this is a big differentiator. We're very excited about this engine. This engine's proven. It's on a lot of, in this exact configuration, it's in a lot of commuter airplanes. So it's got over 116 million flight hours in the field. We've worked very closely with Honeywell to design a test set where we designed the engine mount and the inlet, the propeller. We worked with the Hartzell company to do the propeller. But together we put that all together and ran it in a place called Santan out by Phoenix at a Honeywell location. And so in the top right corner, that's the engine running. And then in August, we're going to go back out with a complete system with the cowl on and the exhaust on and finish that test. And that'll just verify all of our what we call firewall forward or power plant design. The landing gear, another very critical system. It's a trailing link, and that trailing link, that action you see right there is what trailing link does. Makes very soft ride when you're landing, but it's really good for rough field performance. The other real big differentiator here, the main landing gear tires are 24 inches, so they're very, very large, and that'll allow a very high flotation. So for grass strips, short runways, we'll be able to get in and out of a 2,400-foot runway, which is, in this class, is unprecedented. Flight controls, you can't see it, but up in the top corner there's a sketch of an engineer said, here's what I want to do, and then he created a model, a CAD model, and within 45 days from the sketch to the time that on the left was a prototype that was built, and it gives you the direct feedback. This little clip shows you some of the tools that we can use. So this is that piece that you just saw, and it gives you the input for pitch and roll. And this tool is a CAD tool called Kinematics to show you how all the pieces hook together. It'll show system collisions. You can put the loads in there so you know how strong to make these parts. All the arcs that you need to swing, that can all be done inside of our CAD model, and this is an actual CAD model of our system. Avionics is an integrated system. We haven't announced this publicly yet, so if there's anybody videotaping that, this can't be said outside of this room. We're announcing it at Garmin. We're announcing it at Oshkosh, so Garmin 3000. There's 3 screens or 2 screens with a third screen option, 2 other screens for input device. So right here is input device. It's a touch screen. Just like your smartphone, you touch it and change it. It doesn't call up a new app, but it calls up all the different functions. The main screens have this is called synthetic vision, and you see the mountains there. If you're flying in VFR conditions, you look at the screen, you look out. What you see out the window is what you see on the screen. If you're in the clouds, you see this. Up in the next to it is what's called enhanced vision. That's for night vision, so you can see the ground at night. We have traffic avoidance systems. The augmentation for the autopilot down the bottom, that electronic stability. The purple thing says if you get into a real steep bank, the autopilot will, if you're hand flying it, the autopilot will actually push against you and telling you you're getting a little too steep here. It doesn't take over, but it pushes against you. In the aircraft, wireless high-speed internet access, Iridium worldwide phone and weather, XM weather, Nextrad weather in the airplane, data links from the ground, lightning, and up in the right corner is a standard onboard active weather. You can't see the pictures here, but we have a 6-seat in the bottom right. That color picture is our standard configuration with that club seating, so the people in the back are sitting 4 facing each other, and the 2 up front pilots. But we have a 7-seat, and we'll be working on, after the initial certification, an 8-seat also. Stowage, that in the back behind the seats, there's a flexible storage area that all those pieces can be taken out individually, so you can be very, very flexible on what kind of things you can stow. If you take it all out, you can put a couple mountain bikes back there. You could put 6 sets of golf clubs in there, skis, snowboards, things like that. The seats, a lot of work on the seats because the seats have to like in a car, have to hold the person, keep them safe. The seat belt, we have airbags in the airplane, just like in an automobile. So Design CAD. The CAD system we use is called CATIA. It's a best in the industry. Both Boeing and Airbus use it. So we're able to leverage, Boeing and Airbus have been using this for more than 20 years. We're able to leverage a lot of knowledge that they've already helped develop. There's a little video showing some of the details in our current design. So these are wiring and flexible or hoses, fuel lines, and now the air conditioning and heating systems are showing up. The landing gear, the wing is getting a little bit more populated here. The structure's starting to come into place. The engine just popped in there. Now the seats are coming in, the people are coming in, the frame's coming on, propeller and the skins will come on here at the end. So this is how much detail we've got in our CAD right now. So it's very far along. And this shows 2,500 components are currently modeled in our CAD. This is a quick, more detailed look at the power plant. You can see a lot of detail in there. The battery, the power generation system, alternators, starters, all those are in there. Underside the structure, you can see the floor structure, the exhaust pipes, the landing gear, very detailed. And this shows the real, without the skin on, the structure to hold, under pressure to hold the fuselage loads. So certification, I talked about this meeting. This was a very important meeting. The bottom bullet, our next type board meeting with the FAA is in November, and that's on schedule. These two red things, 80% of our, we have to submit what we call area compliance plan, how we're going to comply with all the regulations. 80% of those plans are submitted into the FAA, and of those plans, 75% are approved by the FAA. So our next major FAA meeting, I said, is in November. That's that all those plans will be done and approved by that time, and we're well on plan there. So manufacturing engineering, when we make a part, in this case, in the upper left corner is an engineering design of that's the upper cowl. The cowl is the top that covers the engine. So the first thing has to happen is a master mold gets designed in CAD, and then it gets machined. So that gray part in the middle is a foam block, very dense foam that gets machined, and then we make a layup mold and mold it. And the bottom gray color is the final part that's made. And then you see in the middle it says ply cutting. That shows how all the orientation of all the carbon fiber goes. And on that furthest to the right, bottom right, is laser ply placement. That piece of black you see there is a piece of carbon fiber. There's a green laser beam that's showing the technician where to lay it. So we've done all that testing to be able to do that kind of work. The manufacturing engineer's responsibility are all those circles. So we've got manufacturing engineers on board, I think about six of them right now. This is an actual tool that was made, so the machining, and then the middle part where it's green is the being laid up to make the tool, and then after the tool's made, the black is the carbon fiber tool upside down. Every piece of major piece. So in this case, it's it's a fishbone diagram, we call it, of the horizontal, that back tail section, just the horizontal section. All these pieces, every one of those is a tool that has to be made and a part that has to be made. They all come together to form the horizontal. For this airplane, we're going to be designing and building about 250 to 280 composite tools. This is just one example. And here's a couple others. The top one is the cowl. The middle one is the horizontal, both the surface of one of the skins and then the structure behind it. And the bottom is a little hard to see, but it's a 1/3 scale door, and we've got it so you push a button and the door closes and opens, and we're modeling all that and checking the loads on all that. And these are some other tests that are happening. the 100-inch fuselage I mentioned earlier. We're going through a series of tests on the spar, the main spar of the wing. That says full scale, but it should say quarter length spar, but it's full scale size but quarter length, and the cabin door model. Program management, one of the biggest things here is making sure we know what our bill of materials is. In that bottom right corner, you see 80% of the bill of materials is under contract or quoted by suppliers. So we're well along in we've got either contracts or firm quotes from our suppliers for the majority of our design. These are some of our suppliers: Honeywell, Hartzell, Triumph, Garmin. They're all very, very big in the industry. Parker, Goodyear. Pretty standard in our industry. We've got more than $11 million worth of either absorbed hardware, where they're giving us free hardware for our early airplanes, for our certification airplanes, or engineering design support that they're providing, and they've committed to that number. A very high-level schedule. We've got a 3,000-line schedule that's very, very detailed about every one of those pieces we talk about. In this schedule right now, I won't go through these, but anyway, this is a top 15 or 20 milestones, and then this is the certification milestone. I want to go back to jobs. The thing about jobs that I didn't mention before was today, of that 55% or 60 people in Superior, that's a $4.8 million annual payroll with an average salary around $80,000. In Duluth, we still have 6 people over there. Those are more, we left our heavy machinery over there, so there's some technicians over there. And in Brunswick, we have 44 people. So that's it. Very fast, but I could present for a couple hours on this stuff. Is pretty easy, but I know I didn't have that much time. So thanks for your attention, and any questions?
Council, any questions?
And if you have questions, I'm deaf in this ear and a hearing aid in this ear, so I do struggle with hearing in this kind of an environment.
Any questions of Steve? Councilor Sweeney?
Sure. Thank you very much for the presentation. My question is fast forwarding probably further than you're willing to go yet, but when do you feel the total design package will be certified by the FAA?
That is a fast forward question. It's almost completely funding driven, and we're not fully funded. If we were fully funded, I would say that would be about 2.5 years. So funding is, and I can't speak to funding. I don't
Right.
have details on that.
Thank you.
Any other questions? Councilor Herrick?
Yeah, every day I get a lot of, well, not every day, but it seems like every other day I get a lot of questions in regards to, when are some of these, installation buildings going to be built, and, how long are we looking at?
To build the flying prototypes?
Well, the prototypes, and then also having the plane actually being built here in Superior. About how long are we looking at?
The same time frame. If we're fully funded, the first airplane, some of the pieces of the first airplane would most likely be built in Brunswick, just because we have a facility there. But we're going to fly it here, just do the final assembly here, and then the second 2, we have 3 airplanes that are going to be part of our certification fleet. The second 2, the goal will be to build them completely here. Maybe a little bit out there, but not much. Mostly all here. And then before we get certified, our plan is to start building 5 production airplanes before certification. A little bit at risk, but by that time, the risk will be pretty well mitigated from a design standpoint.
All right, thank you.
Any other questions?
Mr. Hoag, did you still want to speak? Okay.
I'm Ken Hoag, and I was on the city council in Duluth when the same thing was going on with Cirrus, and I feel a responsibility to come to you and say that this is the kinds of questions. I'm not surprised at all, the questions that you were asking, because these are the questions we were asking too, and it takes longer to do some of these things than we would hope that it would. And it takes some patience and some time, and things, went slowly, it seemed like, but they were going as fast as they could go. And this is something that I think is very important to the people of not just Superior and the area, but also Duluth as well. Because if we have two functioning aircraft companies in our areas, this is going to bring all kinds of people to us, and they'll be making their own choices about what they want to buy or don't want to buy, but it's going to be a plus for us, and we will probably have, if that happens, we will probably have the largest private plane thing anywhere in the country, and maybe in the whole universe. Who knows? But I think it's something that to take seriously. It's something that's very, very important, and I think everybody is going to win from this, and that's really all I have to say. So thank you.
Thank you very much. Before we seek approval of the minutes, I'd like to enter into the record a proclamation. Whereas this is for Bob Brown. Whereas Lake Superior is one of the world's largest freshwater lakes and is essential to the quality of life and economic viability of the cities, villages, towns, counties, and tribes along the shores and in the surrounding basin, and whereas water is life and the quality of water determines the quality of life, which is the 22-year-old vision statement for the Lake Superior Binational Forum. And whereas Superior City Councilor Bob Brown has been a member of the Lake Superior Binational Forum since 1998 and wholeheartedly supports and practices this vision in his life, and whereas Bob Brown was a founder of the Lake Superior Binational Forum's launch of Lake Superior Day in 2004 to encourage communities around the lake to celebrate an annual celebration for the world's largest lake, and whereas Bob Brown organized the first Lake Superior Day event in 2004 on Wisconsin Point in Superior, Wisconsin, to honor this great body of water. And whereas Bob Brown was the main organizer of the annual Lake Superior Day picnic and festival in the city of Superior for 6 years, I, Bruce Hagan, Mayor of the City of Superior, do hereby proclaim Sunday, July 21st, 2013, as the 10th annual anniversary of Lake Superior Day and Bob Brown Day. There will be a celebration on Barker's Island at 1 o'clock this coming Sunday to thank Bob and to celebrate Lake Superior Day, and invite everybody to attend.
Item 4 is approval of the minutes from the July 2nd regular council meeting.
Heard a motion and second to approve. All in favor signify by saying aye. Aye. Opposed? Motion carried.
Item 7.1, Parks and Recreation Administrator Morgan is
Consent agenda.
Consent agenda. Sorry about that. Bob Fensland, and was there a second?
Consent agenda.
Second.
Motion of multiple seconds. All in favor signify by saying aye.
Aye.
Opposed? Motion carried.
Item 7.1, Parks and Recreation Administrator Morgan is requesting approval to award the purchase and installation of 2 sets of playground equipment and port-in-place resilient matting to Minnesota, Wisconsin Playground for the amount of $126,322.84.
Second.
Heard a motion and second to approve. Discussion. All in favor signify by saying aye.
Aye.
Opposed? Carried.
7.2, Assistant Public Works Director Janico is requesting to award the bid for repairs to the sewer and culvert at 25th Avenue East near Newton Creek to RGS Construction for $470,000.
Second.
You've heard a motion, a second to approve. Discussion. Counselor Sweeney?
Thank you. I noted that there was only one bidder. Is this unusual that there be only one bidder, or is it common?
I would say this time of year it's a busy year, and it's also a very complicated project. It's not. There's going to be about a 25-foot cut right next to a bridge abutment. So there's soldier piles, soil monitoring, slope monitoring. So in the case of the complicated nature of the project, I believe that it's not real odd. We didn't get anybody from, downstate or across the bridge or anything. So I don't think it's extremely odd based on the complicated nature.
Okay, thank you.
Counselor Fennessy?
And just taking off of that, you're pretty confident that this price is comparable with other jobs that you've had?
Yeah, I don't recall what the engineer's estimate was, but I believe it was under that. This again, it's 80% funded by federal highway. It was under the engineer's estimate, so they did put forth a pretty good bid, a pretty fair price.
Okay, thanks.
Any further? Counselor McKenzie?
Yeah, Todd, just I wonder if you could just explain the process that it takes to get to getting those 80% funding from the FHA.
Well, the process on this one was we had the storm last June. We had some damage in some different areas. Marina Drive was a spot. 20th Street by the high school was a spot, and they came up to tour a couple of federal highway folks, a few DOT folks, and I took them around and showed them those spots. And the representative from Federal Highway says this is higher than a residential street, so it's on the losing the terminology. Anyway, it's on the system, the state aid system, so it qualifies. Damage was done to a flood, therefore, due to flood, therefore it's eligible. So we took them around all the sites. This was a unique one because it's underneath and has an effect on U.S. Highway 2 and 53, as the river Newton Creek runs right by the pier. And when it was originally constructed, the slope failed, and when they were building the abutment and filled in the creek. So I kind of begged. I said, I think this is very relevant to the program, and they ended up going through it. Now what we do is we submit all our costs, all our design costs, engineering costs, construction costs to Federal Highway, and they reimburse us via. We send them to the state sends them to Federal Highway.
Well, I'm glad you did that. I'm glad you begged to, because 80% that's a big chunk of that.
I think I was down on a knee at one point, but it worked.
Yeah.
So
thanks a lot, Todd.
thanks.
Any further questions? If not, all in favor signify by saying aye. Aye. Opposed? Motion carried.
Item 8.1, Mayor Hagan is reappointing Hattie Krass and Mike Meehan to the Mayor's Commission on Disabilities.
Heard a motion, a second for approval. Discussion. All in favor signify by saying aye. Aye. Opposed? Motion carried.
Item 11.1, an ordinance introduced by Police Chief Legesse and City Attorney Prell, amending the City Code, Chapter 74, Licenses, Permits, and Business Regulations by adding Article 11, Synthetic Drug Establishments.
Heard a motion, a second for approval. Discussion. All in favor signify by saying aye. Aye. Opposed? Motion carried.
That would like me to have one person sign it that would like to speak. Do you want to wait till after the second one?
Now or after?
Either way.
After.
Okay. Item 11.2 is an ordinance introduced by Police Chief Legesse and City Attorney Pearl amending City Code Chapter 86 Offenses and Miscellaneous Provisions by adding Section 86-26 prohibiting consumption of products labeled not for human consumption.
Heard the motion and second. Discussion, Counselor Herrick?
Yeah, I just want to make a comment. I want to thank Chief Legess and Attorney Pearl for really working on this and getting us to come to this meeting so we have the opportunity to approve this and to let everyone know that we are concerned about the citizens, not only the regular citizens, but also the children of our community. So, thank you.
Thank you.
We have one person signed up to speak to this item, Patricia Sundin.
Hi, my name is Patricia Sundin, and my family has been devastated by these synthetic drugs. This is my 26-year-old son. He had a stroke back on November 30th last year. He's just gotten out of a nursing home. He's had to learn how to walk, talk all over again. Partially paralyzed on his left side. His short-term memory is very bad. There's many days he has to call me up and ask me, Mom, what time am I supposed to eat lunch? Or what time am I supposed to eat breakfast? I mean, these are just terrible things. And I just wanted you guys to know that there's terrible things that can happen from this stuff.
Thank you very much.
Yeah.
You've heard the motion and second. All in favor signify by saying aye. Aye. Opposed? Motion carried. Any further business to come before this body? Second. Heard the motion and second. All in favor? Aye. We stand adjourned.